Hello guys and welcome. This is I play 4K, aka I play AK, aka I play 16K, because during this video guys today I'm going to go ahead and show you Serious Sam Fusion, Serious Sam first encounter guys, on a Fusion platform, on a Fusion engine which was released in 2017. I'm going to show you Directx 11 and Vulkan API. Today you're going to see Vulkan API running 12K resolution, the first video, Vulkan API 12K resolution, as well as Directx 11 16K resolution, whopping 16K resolution in Serious Sam under the Fusion game engine or Fusion platform that was released 2017 on single RTX 2080 Ti Turing GPU architecture video card and Core i9 9900K overclock at 5300 MHz, whopping 5.3 GHz guys. 53 multiplier for external frequency and 50 multiplier for AVX instructions, which is 5000 MHz or 5 GHz for the AVX instructions. Let me real quick go ahead and switch the resolution, and we're going to start with DirectX 11. So let me switch to lower resolution so it's not going to crash. Today I'm recording with the ShadowPlay. I'm going to switch Vulcan to 4K resolution first, and then I'm going to real quick go ahead and switch it to DirectX 11. So DirectX 11 versus Vulcan. Unfortunately, Vulcan cannot run Fusion game engine in 16K resolution, and I believe just because they optimize Vulkan very well in this Fusion game engine or Fusion platform of Serious Sam, I'm pretty sure that Vulkan 1.1 will have kind of problems or will struggle at 16K resolution. So what we're gonna do, let me real quick go ahead and switch to DirectX 11. Here we go. We're going to run it guys up to 12K resolution, 4K, 5K, 8K, 10K and 12K. But DirectX 11 we're gonna do at 4K, 5K, 8K, 10K, 12K and 16K guys. So it's going to be nice to see what's going on and everything what we will have over here. So let me real quick go ahead and lower. Guys, today I'm running 8K resolution native plus DSR. So I'm upscaling from 16K, 12K or 10K to 8K native. Okay, so this is going to be guys our 4K resolution. Let me real quick go ahead and show you settings. DirectX 11. 3840 by 2160, 16 divided by 9, 16 by 9 aspect ratio, full screen, unlimited max 3D rendering megapixels, so it's maximum possible what is the resolution allows. Performance ultra maximum, GPU speed ultra maximum, GPU memory ultra maximum. I'm just going to use presets so it's easy to mimic. Max FPS unlimited, so we're gonna see the maximum possible FPS during this test. As again guys, this is not the pixel comparison. Even Monkey knows that 4K resolution versus 16K resolution has a different pixel counts and stuff like that, and 16K resolution will beat 4K at anything in terms of pixel quality and pixel count. But this is guys a computer science video where we're going to see the Turing GPU architecture by NVIDIA performance by that numbers, and so we can compare with the previous GPU architecture by NVIDIA or any other GPU and next future GPU architecture guys, plus 16K resolution, the first 16K resolution in Serious Sam guys under the Fusion game engine, under DirectX 11 and Vulkan 12K resolution, the first 12K resolution ever uploaded to YouTube under the Vulkan 1.1 guys, and this is just incredible. Go ahead, smash that like button and let's go ahead and get going guys. A lot of time, money, energy was invested. In the end of this video guys, I'm going to show you my computer specs within details, but let's go ahead and get going guys. Serious Sam HD first encounter under the Fusion. first level. Let's go and have a look. This is going to be a demo.
Ready for battle.
Look at that single RTX 2080 Ti Turing GPU architecture, guys. GPU running at stock. VRAM is overclock, additionally 1200 MHz or 1.2 GHz. And I have two GPUs, but SLI is disabled. I mean, two video cards, but SLI is disabled. So the first GPU that is running right now 96%, as you can see right there, self-explanatory at the right top. Doesn't have enough air to breathe, and it's pretty much breathing out of the second video card without the slot between them. I'm running it today on Asus Maximus 11 Hera Z390 motherboard, two video cards without the slot between them. So when they're running SLI, they thermal throttling on the first GPU and frequency lower itself. But original maximum frequencies on this EVGA RTX 2080 Ti XC Ultra is 1950 MHz maximum possible frequencies by the manufacturing. And you can overclock above 2000 MHz when you're running single video card, but sorry, I'm lazy and no space between them, so it's going to run a little bit hot, especially when I'm going to run 16K resolution under the Directx 11 in a few minutes. Alright, 90 scalability is almost perfect, guys. Look at that FPS. Okay, I'm going to go ahead and stop it. Let's go ahead and have a look at our 189.2 average FPS. Okay, now we're going to go ahead and switch the resolution. So pretty much maxed out, guys. Anti-aliasing will be off only, but everything else pretty much at maximum settings possible. So DirectX 11 5K resolution, field of view 120, keep that in mind as well. So we're rendering more than with 90 field of view. Okay, 5120 by 2880, 5K resolution. Let's go ahead and get going, guys. Same thing, same test. Amazing, by the way, FPS on the DirectX 11 updated Series Sam HD. That was ported it pretty much it's Series Sam HD, but ported it on the DirectX 11. Amazing for the single video card performance. RTX 2080 Ti, guys, is unbelievable video card. Turing GPU architecture is unbelievable architecture by NVIDIA, and it's the first GPU architecture that allows us, guys, to run old school games at 16K resolution. And over iPlay4K.com YouTube channel, guys, I'm going to show you a lot of games under 16K resolution, including the old school games, including the new school games. So don't miss it out. Go ahead and smash that like button, guys. I support. A lot of time, money, energy was invested, guys. I'm just showing you so we can pretty much speculate. This is the real deal over here, and you're going to make a better choices. Plus, compare with your hardware or compare with the future technology. My videos has a lot of meaning to it from multi angles, at any angle that you're gonna look at them. So a lot of information, guys. Look at that, above 100 FPS, 5K for the single RTX 2080 Ti. Everything maxed out. Yes, it has kind of easy geometry, as you can see, low poly almost. But look at that gun. The gun looking great. Doesn't look so low poly. The barrels, cylinders, I would say still low poly. I mean, the gun will be like maybe 1000, 2000 polygons, but still not bad. Geometry will be easy over here, but as again, it's a great test because we're going to run up to 16K resolution. And guys, keep in mind, when you're running 16K resolution upscale to 8K native in this game, it looks amazing. All the old school games from 16K upscale to 8K looks like on another level. Imagine when you're upscaling 8K to 4K, it's looking amazing. Some people doesn't agree, but they probably never done it, and this is naysayers. But people who done it, they can see how beautiful pixels, details, and everything, even on a 4K native, even if it's upscale from 8K, but it's still rendering 8K in real time. And today we're still going to render 16K in real time, and then we're going to upscale it to, I mean not upscale it, sorry, when I say upscale it I mean downscale it, and then we're going to downscale it from 16K to 8K resolution, guys. As again, I'm apologizing, whatever I said upscale it, I meant downscale it. Okay, so yeah, I commented so many videos for you, so many videos will be uploaded, and I'm losing my voice is kind of squeaky, so I'm apologizing. As again, support me, hit that like button, smash it, and share it with your friends. Positive comments, guys, support me. You know, trust me, it takes a lot of stuff and time and money to do that, guys, and I'm not rich and stuff like that, but you know, I'm sharing a valuable experience here, especially for the community, because this is going to be the first 12K resolution under the Vulcan ever uploaded to YouTube, downscaled to 8K resolution native, and unbelievable. As again, it's rendering at that 12K resolution, guys, and then it's downscaling, but it's rendering. So when you're going to see Directx 11 today's 16K resolution, it means 133 megapixels rendered and then downscaled. So no matter if it's downscaled or not, it's going to be the same results, plus minus 1, 2, 3 FPS when you're going to run it on native 16K resolution screen, because it's rendering those pixels, guys, in real time. Alright, above 100 FPS. Okay, let's go ahead and have a look exactly by how much. 120 average. Okay, you saw the GPU scalability, guys, after the temperature, and I put the cores for you, 6 cores. Today I disabled 2 cores and I disabled the hyper threading, so I'm running just 6 cores, 6 threads on the i9-9900K. This is how you want to do it, and I clock it to 5.3 whopping gigahertz, so the faster frequency the better. The course doesn't make any sense, as you can see by the stats as my facts to you. 8K 16 divided by 9 aspect ratio, guys. Let's go ahead and have a look, shall we? Here we go. So guys, for the future gaming, 6-core CPUs will be good to go. Maximum 8K, 8 cores, not 8K, 8 core CPUs. But as again, 6-core will be good to go, because as you're gonna see, as I'm going to increase my resolution, I'm going to decrease my CPU usage. So CPU usage, we want to have lowest possible values, guys, but GPU usage we want to have as high as possible values, because we need to utilize GPU in the games more than CPU. So this is the rule. So CPU is great when it's utilized. Look at that, CPU utilization below 20%, and it's only with 8K. Let's see when I'm going to show you 16K, guys. 11-12% right now overall, and you can see it's split it to the 6 cores load. Unbelievable. So it's great when the CPU utilization is lowest as possible. It's great, but GPU utilization should be above 95% for single video card, and when it's 99 and 100, this is excellent GPU utilization, and we want to keep it at above 95% at least to keep it excellent. But I mean, when it's 99-100%, it's amazing, fantastic GPU utilization, and it should be stay that way when you're running single video card. But it's kind of hard for tuning GPU architecture, and it's not the CPU bottlenecking like those fools saying. CPU bottlenecking happens only when CPU is overloaded, when it's like above 97% CPU utilization, and anybody knows that higher frequency will show you higher FPS, but it's not going to, higher frequency is not going to load your GPU at higher values. It's not going to happen, guys. My GPU utilization will be the same at 3.6 gigahertz on the CPU stock per core, or 5.3 gigahertz per core. It's going to be the same, but FPS will increase, and because the frequency per CPU is increasing your FPS, not the core count. So utilization, if utilization below 97%, you're good to go. There is no bottlenecking. Alright, let's go ahead and have a look. Average 57.9, not bad for 8K resolution for a single video card. Still playable under 60 FPS. Now I'm going to real quick go ahead, guys, and show you the 8K for the native TVs as well, some resolution. 8192 by 4320. Okay, as again, rule is everything maxed out. Okay, let's go ahead and have a look. Look at the delay in milliseconds, guys. If you want to keep it as low as possible. When delay is above 30 milliseconds, it means there is a stuttering and there is a possibility of the lag. Okay, lag free gameplay for the newer games that was released in 2018, 2019, 2017, lag free will be below 10 milliseconds and without the stuttering. 10-20 milliseconds, a little bit of stuttering, just a little bit of stuttering, but lag free. 20-30 milliseconds latency delay will give us some stuttering. You will feel some stuttering and maybe sometimes lag. But 30-40-50 milliseconds and above, it's going to be laggy and stuttering, so keep that in mind. But at least we can run 16K resolution, because the previous GPU architecture, such as Maxwell GPU architecture, couldn't allow us to run a 16K resolution, and I don't believe it was just a VRAM issue. But Maxwell, Titan X Maxwell had 12GB VRAM and compression for that VRAM, because, guys, I find out, yes indeed, Turing compressing almost 2 times by NVIDIA data, shared data, 2 times compressing data before sending to VRAM versus Maxwell GPU architecture. So, and Pascal GPU architecture, as I find out, about 1.3, 1.5 times using more data when storing to VRAM. But Titan X Maxwell used 2 times more for the same scenarios, and it could be VRAM issue. That's why it couldn't run 16K. But as again, I have a little bit doubt of that, because by the milliseconds, you know, under the latency, when the 4 Titan X Maxwell GPU architecture was running 8K resolution, it was very high. It was above 30 milliseconds at 8K resolution, and I think so we are right now cutting by 2, as you can see, even in latency delay. And I think it's a GPU architecture pipeline, how it's you know, processing the instructions and data. And I think maybe it could be possible with Titan X Pascals, Titan XPs, the second generation of the Pascals for the Titans. Still GP 102 is version 1 and version 2. It could be, but I couldn't, except the Half-Life 2. I couldn't run the Counter-Strike at 16K and a lot of games at 16K, but with Turing it's possible. So I would consider the Turing will be the full architecture that allows us to run a lot of games at 16K that it wasn't before possible with 4 Titan X Maxwell GPU architecture. And 4 Titan X Maxwell GPU architecture, guys, will be still faster than 2 RTX 2080 Ti video cards in raw rendering, when the 4 Titan X will be loaded at 99%, 95%, 97%, 4 GPUs, 4 video cards in SLI. They will be a little bit faster. Okay, let me go ahead and switch it. There will be, let's go ahead and have a look at our average FPS. Sorry, I missed the point. Average FPS 54, not bad. 8K resolution, 84 TV, 500 megapixels, more than 16:9 aspect ratio, but still at 60 FPS, not bad. Let's go ahead and switch it out, guys. This is under Directx 11 yet, and now 10K resolution, and I will continue with my talk, guys. 10K resolution, because I'm sharing valuable data, guys. This everything what I'm sharing, it's not like those non-sayers. Everything what I'm sharing, guys, comes from the real experience. It's not like from those fools or copycats. They just copy somebody else's information, or those copycats reviewers. They just rushing and reviewing and telling you what you need to know to get the subscribers and views. And I'm not telling you what you need to know. I'm telling you the way it is. And let me real quick increase our, here we go. So we're gonna see exactly what's going on. Wow, 30 FPS. So yeah, 10K resolution, struggling. As you can see, milliseconds, below 30 milliseconds. So it's going to be stuttering at this point. It's not going to be lagging, but it's going to stuttering. So for Directx Maxwell GPU architecture was running like this, or even higher on milliseconds. So you felt that stuttering when you were running 4 Directx Maxwells with the 4 Directx video cards in SLI. The titles that was released in 2015 and 2016, 2017. That was tested. You were feeling that stuttering a little bit, but it was stuttering there. And right now we're going to probably also feel a little bit stuttering. But this is how 4 Directx Maxwell GPU architecture was running, guys. 8K resolution, even sometimes above 30 milliseconds. And we're running right now 10K resolution. So Turing GPU architecture has advanced pipelines, as you can see, for processing the instructions and data. And as I consider, it's the first video card that at least can run 90% of the games that was released before 2016. I would say not before 2016, but before any games that was released before 2010 can run 16K resolution, and a lot of games that was released before 2014 at 16K resolution. As again, the FPS will be variable, but it can run. And 4 Directx Maxwell GPU architecture video card couldn't, and Pascal could a little bit at higher resolution, but also was struggling. And I believe it will struggle to run this 2 Directx piece if it ever will boot it up. And as again, I don't think it's a VRAM issue. I believe it's just, alright, let me real quick go ahead and switch it now. I believe it's just pure 31 FPS, guys. I believe that this is just pure GPU architecture pipeline, the way it's, you know, allows to proceed its instructions, store the data at the same time, to capable, they all capable run 16K resolution textures, but it doesn't mean that it's going to run 16K resolution render real time. So keep that in mind. And I believe Titan XPs and Titan XPs and Turing GPU, which is Pascal GPU architecture, and Turing GPU architecture, which is Titan RTX, as well as RTX 2080 Ti or GTX 1080 Ti for Pascals, are capable of around 32,000 pixels as a texture. But as again, it doesn't mean that it's going to run the render on the full screen. Alright, guys. So 12K resolution now. Oops, not 16K. We're gonna do 12K resolution, 11,520 by 6480, 16 divided by 9 aspect ratio, 12K. It's going to accept it. As again, I'm recording with the ShadowPlay During this gameplay, guys, I find out that ShadowPlay takes only 2 FPS. So add 2 FPS to get the real FPS without the recording. I'm so honest, so I'm providing you the information the way it is. So just add 2 FPS to get the real FPS without the recording. We're about to switch, guys, to 16 to whopping 16K resolution, and then we're going to switch to Vulcan. I'm losing my voice. My voice is squeaky. I'm apologizing. Recorded a lot of videos, so that's why you gotta smash that like button if you want to see more 16K and crazy cool videos with a lot of values and information, guys, for you to think about it. If you're building a new computers, or if you're following just GPU architecture and thinking with the old hardware and thinking one day you will build one. As you can see, we're experiencing it together, guys. Look at my CPU utilization, below 20%, 12K resolution. Let's see if Vulkan will be faster, but Vulkan cannot run, guys, at 16K resolution, so keep that in mind. It's going to crash. And this is going to be Vulkan 1.1, and this Vulkan 1.1 is capable of SLI. It's capable to create virtual device, so it's going to utilize all the GPUs. It's not like SLI scalability, but it's capable to utilize any GPUs that is connected on a computer in kind of virtual device. But it's up to the developers, because SLI is supported not up to the developers. SLI support actually through the drivers, guys. So do not, make developers reliable for SLI scalability in their games. It's up to the drivers. But Vulkan API 1.1 that now we are using within our Fusion game engine, by the way, excellent idea by the serious Sam, because it's going to be in favor a lot of modders. You can do a lot of mods, guys. I'm going to record Duke Nukem under this Fusion game engine with the newer graphics, and it's going to be a lot of games released under this game Fusion, so it's nice to test it. And this Fusion platform or game engine will support Directx 11, Directx 12 API, Directx 12 API crashing above 8K resolution right now, and I don't like Directx 12 API, to be honest with you. It doesn't support SLI, it's crashing, and so pretty much this Fusion will be good to know for Vulkan, because you can run it under the Linux and under the DirectX 11, under the Windows. So whatever API you wanted, today we're going to find out which API will be faster. Vulkan should be faster as DirectX 11, but we will find out if will be the case. DirectX 11 more bulletproof because it can support 16K resolution, and Vulkan, updated Vulkan, it's going to be next level Vulkan that was used in Doom. This is going to be the next updated version, is not capable of 16K resolution, unfortunately. So it's not that bulletproof, guys. DirectX 11 more bulletproof because it can run any resolution that you're going to throw at it. And as again, today I'm running AK native and plus DSR. So we're going to downscale it. Right now we're downscaling from 12K resolution, but we're rendering 12K resolution pixels in real time and downscaling to 8K resolution native, guys. And keep in mind, this is how it's going to be on 12K resolution screen or 16K resolution screen set at 12K resolution. Alright, good to go. Let me real quick go ahead and stop it. Let's find out our FPS, and the average will be 27.9. Could be playable, but you saw the latency delay was above 30 milliseconds, so it was stuttering. But for old school gamers, guys, that used to play 30 FPS, yeah, with mid-range video cards back in 2005, 2002, is going to be good to go. But the visuals was incredible, by the way. So let's go ahead and switch to a 16K resolution. So 16K resolution, guys, this is going to be amazing. I'm falling asleep, unfortunately, but you know, I'm so excited. But I already saw it. I was so excited. I just lost so much energy because I was so excited when I saw it's capable of around 16K resolution, because previously I was crashing with Maxwell's for Titan X Maxwell's video cards, and I was crashing as well with the Pascals at 16K, but now we're capable. So Turing GPU architecture, guys, is going to be future proof, and purchase it used in 2020 for half price. So this RTX 2080 Ti video card will cost, guys, 600 bucks on eBay like new. Go ahead and purchase it in 2020. Even the Titan RTX will cost like around 600-700 bucks if you can purchase that. And pretty much Turing GPU architecture will be good to go up to 2022, guys. 4K resolution, as you can see, it can handle like a champ. Above 100 FPS, no matter what kind of game you're gonna throw it at maximum possible visuals. Look at that FPS. Delay is, that's it, stuttering. About 50 milliseconds. Yeah. We lowered our GPU usage, as you can see, 13, 9, 12%, 12%, sometimes jumping to 24, but pretty much mostly we're utilizing, like, look, so low utilization per core. Okay.
Now that's
15
serious
FPS.
firepower.
So it's renderable, we can say it that way, but it's not playable. But the details, guys, those pixels are amazing. And for those goblins that will say the textures is not ready, that when textures are not ready, but at those resolution 8K and above, even when texture is 256 pixels by 256 or 512 pixels by 512 pixels, it's still looking on another level, because the object's much smaller, because you can display more vague 3D models on the screen that's capable at 1080p, guys. And that's why those textures become smaller, because all the 3D models become smaller, and they kind of naturally fit to it, and creating you the illusion. And it's not only the illusion, because it's fitting those pixels exactly the way it should be, and it's displaying all the pixels, so even the low resolution texture is looking amazing on another level. Trust me, those people who downscaled before from, you know, much higher resolution that they screen capable, they can tell you that I'm right, guys. And mostly naysayers, they never did it, so they probably will never own the hardware as well. So whatever they're saying, you know, they're trying to teach us, but who listening to them? I'm just laughing from them. Look, 99% utilization, 99-100, excellent GPU utilization. So the higher resolution, the better GPU utilization, guys. And this is how we want to keep it, and we want to keep our CPU utilization as low as possible. But as again, for the future 6-core CPUs, guys, good to go. So I would say Core i 9th generation CPU, guys, purchase it, you will be good to go. If you're buying right now in 2019 computer, purchase i 8th generation, and make sure you're purchasing i5 8600K, the first 6-core CPU, and you can do i5 9600K, which is the 2nd generation 6-core i5 CPUs. And clock at about 5 GHz, your performance will be almost the same, guys, plus minus 1-2 FPS. But buy yourself i 9th generation i5 9600K in 2020. Get it for half of the price, and you will be set to go to 2022, 2023 at anything, guys. Plus you can render, plus you can do whatever you want to do, guys. If you're not rendering 8K resolution videos for the YouTube, then you're going to be good to go at 4K resolution, guys. You're just going to be good to go, trust me. Alright, I think 15.9 average. Okay, even 3D rendering, because I'm graphic artist, I'm 3D artist as well. I'm YouTuber, so I'm uploading a lot of videos. It's good for me, guys. And if you're gonna get i9 9900K, which I consider waste of money, yes, you will be speed up by a little bit at video encoding, but not that much, trust me. Alright guys, so let's go ahead and lower the resolution. So it was, guys, 16K resolution, and now I'm going to lower it and we're going to switch it. Let's go ahead and do the 8K resolution. I'm just going to lower to 8K resolution, and then I'm going to switch the API. I don't want to switch the API at high resolution because just because I'm recording, it can crash our GPU connection and connection to the device, and because it's under the heavier stress right now because I'm recording with a ShadowPlay. So let me real quick switch to Vulkan. We're gonna skip on Directx 12 because Directx 12 in this game cannot run above 8K resolution, and in most games as well. It's struggling. It's crappy. Directx 12 crappy API, guys. Doesn't utilize SLI and stuff like that. Alright, everything maxed out as we got Vulkan 4K 16:9 aspect ratio. Let's go ahead and have a look, guys. Let me real quick reduce the screen for you. I'm apologizing. As you saw, I was running at possible maximum 16K, so we couldn't do anything over there, guys. We couldn't do anything over there. Alright, Vulkan. As again, guys, I'm commenting in real time as well, and it's kind of hard, so don't forget, smash that like button. You saw a lot of good stuff. And those developer cheats enabled, it's just because I'm running the demo. So it's a recorded demo that renders in real time the demo that was played and was recorded, and now I'm playing it. So it's kind of the same movements and everything is the same, so it can be used as a benchmark easy. 170 FPS, 169. Let's see if Vulkan can overperform DirectX 11 API. It should be, because Vulkan should be faster. It's eliminating a lot of dependencies that DirectX 11 using, and some of those dependencies comes from DirectX 9 and even DirectX 8 API, and they kind of slow, like direct input, direct surface. They come all the way from DirectX 8, DirectX 9. Direct device and such a stuff like that. And Vulkan kind of eliminating, it's using the faster dependencies that was designed after DirectX 8 and DirectX 9. It should utilize better, but we're going to find out. Alright guys, let's go ahead and have a look, shall we? Because we gotta get going here. 159.4. So go ahead and compare with 4K DirectX 11 and you're going to know your numbers. Now we're going to go ahead and 5K. Okay, I took it, nice. Thanks God that ShadowPlay can record Vulkan, OpenGL and DirectX. ShadowPlay is such a great technology, guys. It's just unbelievable. The fastest video capture of gameplay, guys, or anything that you can see through your Directx API. There is no software can be faster than ShadowPlay, because I believe ShadowPlay is connected with NVIDIA hardware, and it's probably using even the chip on NVIDIA video cards. Because it's not just the software
Now that's some serious
emulation.
firepower.
Because like a GTX 1050 cards doesn't support ShadowPlay. So as I find out, so it's there is a chip on the video cards, guys. As again, the developer cheat enabled it just because it's demo, and when you're playing demo in Serious Sam, it's showing that. And why I'm playing demo, because you know it was played once and then recorded, and we can play it over and over and over again and test it with all kind of hardwares and stuff like that. And this is pre-built demo, guys, in Fusion game engine of Serious Sam, and we can compare it in the future, save movements and stuff like that. Alright, so 5K resolution. Let's go ahead and have a look what we got. 102 FPS. I think it's slower than Directx 11. So guys, you know, I think Vulkan faster than OpenGL, but I don't think it's faster than Directx 11, because under the Doom it's faster than, as we saw, than OpenGL. Vulkan on a single video card is almost faster, a little bit a hair slower than OpenGL with SLI, newer OpenGL 3.1 version. But okay, 8K resolution, guys, 16:9. But as you can see, DirectX 11 is whopping Vulkan at 5K. Oops, I think I clicked no instead of yes. I'm gonna redo it. Yep, I'm gonna redo it. So 8K. So it lost. I can tell at 102 FPS it's much lower FPS that we showed with DirectX 11. 5K. So 8K, guys, let's go ahead and have a look. So we're gonna see how Vulkan performs at different resolution, what kind of delays as well, how it takes that stress at much higher pixel count. So this is great, by the way, Vulkan video, guys, so technical. 49 FPS, wow, not good. 21 milliseconds delay, also showing higher delay as well by a couple milliseconds. And the FPS much, guys, lower than at DirectX 11 at 8K. We got this FPS, we even got the faster FPS at 8K native TV, which is 8192 by 4320, but right now we're running 16:9, which is 7680 by 4320, which is for most of the monitors, 8Ks. And some of the TVs. Vulkan. And I believe they're using Vulkan 1.1, correct me if I'm wrong, but at least Vulkan 1.0, and we saw how Vulkan 1.0 performs in Doom. But it performs in Doom when comparing to OpenGL, but doesn't perform well. When it comes to DirectX 11 comparison API. Guys, OpenGL, I tested Quake 2 and Quake 3. Tried to do it at higher resolutions. Unfortunately, there is no 16K for Quake 2 and Quake 3 with the Turing GPU architecture. So Carmack didn't envision that, and I think it's a game engine issue. or maybe it's OpenGL issue. I'm not sure yet, but we're going to find out. Let me know in the comments below. It could be the OpenGL issue. With 3.1, with the white Quake, which using the latest OpenGL, it wasn't possible above 8K resolution. The highest possible was 8K resolution, and then it was just freezing the OpenGL surface. It was just disconnecting from OpenGL surface. Look at that usage, almost 10 gigabytes, 9,972 megabytes. Very high usage, guys, of the VRAM under the Vulcan. Vulcan utilizing more VRAM, guys. So Directx 11 API, guys, I consider this as the best API ever, because Directx 11 API can support 4 video cards in SLI. So far, even in 2019, Directx 11 API, guys, is the best considered by I, and this is the facts. 39 FPS, come on, 39 FPS. Alright, let's go ahead and have a look at the average. What is the average? 45 FPS, come on. Vulcan. Let me increase just 8K 16:9. Let me increase the 8K native TVs, and it's probably going to tell us sorry, not playable FPS or what. Let me increase the stat for you so you're gonna see it perfectly now. Please watch this video, guys, on a monitor, high resolution monitor, so, and switch in a video player, high resolution in the YouTube video player. So okay, let's go ahead and do the 8K, which is some of the TVs we'll use as native. Let's go ahead and have a look, shall we? I know it will take it up to 12K. 12K it's going to struggle a little bit. It's taking 16K, but then it's crashing, so keep that in mind. So 8K like that, guys. Let's go ahead and have a look, shall we? Let me real quick lower. I think under the Vulcan we don't need to go that high. Lower a little bit, then I'm going to increase it. Okay.
Ready for battle.
VRAM usage 10 gigabytes. It's going to reach 10 gigabytes, I think, guys. Maximum possible VRAM usage right now it's 9968 megabytes. Maximum possible is 11,000 megabytes. Keep that in mind for RTX 2080 Ti during GPU architecture video cards, guys. But what I find out when we're reaching above 10,000 megabytes, same thing, same diagnosis as it was with GTX 1080 Ti, guys. After 10,000 megabytes, the video card is acting weird. It's receiving a high delay, latency delay in milliseconds, and it's generating above 10,000 megabytes a little bit of stuttering. Let's go ahead and have a look if it's going to be the case over here. Of course, we can see a little bit of stuttering, but it's still playable. It's below 30 milliseconds, but we almost reached to the point when it's going to stuttering and we're going to feel it. So it's not going to be like comfy. Yeah, as you can see, Vulkan API is not the fastest. That's all the naysayers' illusion. This is the facts. Maybe Vulkan will be faster than I'm running right now under the Linux. Go ahead and test it, let me know. comparing at least at 4K resolution, but I have doubts. Try to use the same hardware, about 5 GHz and RTX 2080 Ti. Again, I overclocked my VRAM by 600 MHz today, which is 1200 MHz additional external frequency, or 1.2 GHz, because GDR6 that is equipped on our RTX 2080 Ti video card is up to 14,000 MHz or 14 GHz, and as you can see at the right top, we are 15,200 MHz, which is 1200 MHz additional overclock. Yeah, below 30 milliseconds, so it's going to stutter just a little bit, but you can already feel the stuttering, guys. 45 FPS. GPU utilization 99%. At least we're utilizing 99% our GPU. I think Vulcan crashing at 16K resolution, guys, due to VRAM on the RTX 2080 Ti. It's overloading the VRAM. So I'm going to test it with Titan RTX, and we're going to find out for sure, guys. Okay. Oops. I click escape and look what happened. Look what happened, guys. What it is. I can tell you what it is. We probably, the ShadowPlay probably done with recording. Average FPS 417 FPS. I don't think so. I think the ShadowPlay done with the recording, but our FPS was like 45 average. Done with the recording, or come on, or just VRAM issue was and slow down. 10,000. So 10K resolution, guys. Hopefully the ShadowPlay is still recording. I'm so hoping for this. We're almost done, guys. Almost done. Come on. So 10K resolution, guys. I'm pretty sure at 12K resolution we're going to overload our VRAM. I'm gonna bring it to its knee. 10K resolution. Alright, benchmarking. $11,000 megabytes. Did you see that? And then it went back to 9463 megabytes. I think Nvidia was cheating over there. Look at our latency delay. So this is stuttering for sure now. About 45 milliseconds. But did you see that 11,000 megabytes? I saw that, guys. And look at my system RAM. After the frequency under VRAM, 13,000 megabytes, almost 14,000 megabytes. My maximum system RAM is 32,000 megabytes or 32 gigabytes. We loaded our system RAM, so Nvidia is cheating. So it's, or maybe it's Vulcan API. So it's reached that maximum cap, because I saw above 11,000 megabytes on the VRAM, and it just start loading the system RAM. But system RAM is slow. So it's pretty much generating higher latency delay between the GPU API, which is Vulkan API, and VRAM when it's storing it. And yeah, I think it's using a little bit of system RAM, guys. Maybe 2 gigabytes. Not all, but 2 gigabytes, and it's still going to generate that latency and stuttering. You're gonna feel it when it's going to get access to it, and when it's going to store the data to that frame buffer and the system RAM. It could be Nvidia driver doing that, or it could be just a Vulkan API does it without the driver involvement. As again, I never programmed for Vulkan API, I have no idea, but I'm pretty sure that Vulkan API can 1.1 version can utilize 2 video cards, 4 video cards, 3 video cards, and it's not acting like SLI. You need to have driver support. It's just a virtual adapter, guys, that can accept all those GPUs into one virtual kind of video card, and it can have multiple real video cards with the GPUs in it. But as again, it's up to the developers, and I don't think, and I not only don't think, I know for sure that Fusion Engine that we're running today from 2017 Steam version that was downloaded in 2019 doesn't support multiple video cards under Vulkan. But there is a Quake 2, guys, that supports under the Vulkan SLI. Keep that in mind. Which means not SLI but multiple video cards. It supports 2 RTX 2080 Ti. But unfortunately it doesn't support above 8K resolution. Kinda suck. And what Quake I'm talking about? I'm talking about RTX Quake 2, because it's running Vulkan API. I mean, it supports 16K resolution. It does. Actually, it does support 16K resolution, guys. So I'm going to record you probably a Quake. We're going to find out. I think it supports 16K resolution. Quake 2 RTX version with the ray tracing. I believe, because it's running Vulkan, and I believe it's supporting 2 video cards, and I think I will be able to run it with 2 video cards. We're going to find out, guys. Don't miss it out. www.iplay4k.com for more information. This is, guys, 12K resolution, so the last test. Let's go ahead and have a look at our FPS. It doesn't support 16K resolution, is not supported. We saw that overload 23 FPS. Slower, much slower than, guys, Directx 11 API. So we got our question answer during this video today in real time, real life scenarios. Hopefully I'm still recording with the ShadowPlay because it has the limitation. As you can see, my overclock and MS Afterburner only plus 600, which is 1200 megahertz additional overclock. Okay, my CPU was overclocked to 5300 megahertz. External maximum frequency 53 multiplier or 50 multiplier for 5 gigahertz or 500 megahertz on the 5000 megahertz, sorry, on the AVX instruction. As again, motherboard Asus ROG Maximus 11 here, Wi-Fi model, Z390 chipset. Video cards doesn't have any space between them on this motherboard. Keep that in mind. So SLI, you want to have first slot water cooled, or get yourself MSI Z390 Godlike or Gigabyte Aorus Extreme. You're going to have some space if you're planning to run on air, because on air video cards will survive longer than on water, uninhibited water cooling, because the pumps will go down, guys, after 3 years. The highest single-threaded, single-core performance, even if Intel will release newer CPUs in the end of 2019, at stock, they will never reach this single-thread performance. Keep that in mind, guys. The best gaming CPU, Core i, 9 generations, alright? Thank you guys so much for watching. As again, iPlay4K was with you today. Don't forget to smash that like button. Right now I'm putting some cool videos for you to watch, and I will see you in the next videos, alright?